The full test of the solar system that I have. Basically, I'm using a power supply on the left here to simulate the solar panels. Now it's 37 volt, 3.66 amp. I'm using 12 volt, 8 amp hour battery. And I'm using the solar charge controller that I have here from EP-Ever. And this is kind of the machine that I'm going to show you. Here you have the controller, and that button here is turning the load on and off. You have the same button on the charger, on the solar charge controller as well. But that's kind of normal for those things. Now, if you want to see what we are doing here, so we consume 2.5 amp for the load. We are consuming 5.4 amp for charging the battery. And here we have 36 volt, 3.1 amp, which is giving you higher wattage of what we need. So that is basically the controller itself. That's a controller of the solar charge controller, the display and control. Here's the solar charge controller working, and as you can see, it has both PV on and battery on. This is basically, we are charging the battery, and we also have enough power from the PVs to do the work. Now, if I would reduce the voltage of the solar panels, what's going to happen? It's going to basically think that something is wrong, and it's going to start tracking this again. As you can see, I reduced the voltage to 0.17. Then the PV went to, actually it's a solid light, you don't see it yet. And here, as you can see, we are not having the full work, but it will find a point, and then it's going to increase the current, and then we're going to get, again, some power conversion. So now you can see that it ramps up the current because it finds the new optimal point, and then it's going to stabilize itself. Probably it's going to overcurrent my power supply because it's only 5 amp 60 volts, and now we don't have enough basically power, so it's going to make sure it consumes as much as it can from the solar panels at this voltage. It's going to stabilize itself, and still okay, less than 5. And again, you can see that both lights are blinking, meaning we are charging, and we also are having a load here. Just I turned off by mistake. You can see the load now is going to show as now you see that the current went to the load as well. So we have 27.1 volt with 4 amps, so it's basically more than 100 watts going in. The battery itself is consuming 14.3 times 5.2, which is about 60 watts, and the rest goes to the load. If you do the math, it's going to show you that we have an input, and then we have power for charging and power for the load, and of course there's some losses which are taken care of as well. So that's the full system. Again, that's the simulation of the solar panels. Here we have the battery, and here we have the solar charge controller itself, and here we have the controller and display for the solar charge controller. Just bear in mind there is a wire that you can connect it to the system and have it remotely. You can even have an extension wire which is bigger than that. So the system was working perfectly well and to the spec, and I'm very happy with it.